Today we are going to do a little bit of practical session. In this practical session, we are going to deal about the SPSS, how the SPSS actually functions. We will take some of the tests because there is a shortage of time and numerous tests are there. It's not possible like within 1.5 hours I'm going to tell you everything. And even you, like even if I tell you also, so it's not possible for a human brain to to grab everything in a single moment. So we will start with the t-test, types of t-test as well as the ANOVA regression, and one or two tests of non-parametric. uh, Next slide please. Ranjit ma'am, please. Hello, Ranjit ma'am is there? Ah, please get the next slide. Okay, so this is how the SPSS data view looks like. So we have to import a data. We will come to the practical session, how we will input the data in this software. And there are certain techniques are there that we have to follow. But before that, we will learn or we will see some of the preliminary section where we have to know about certain things before importing the data. So I want to ask people who are not having a clear knowledge about the research, do you have any knowledge about the categorical variable? Which are the categorical variable? Any idea? See, variables are of two types, like dependent and independent. Okay, mostly we work with these two variables. And within this type of variable, we also have a categorical variable. So, do you have any idea what is this dependent and independent variable? Anyone? Okay, so dependent variable is nothing. Dependent variable, please listen it very carefully if you are not having a clear idea, because your whole thesis or the research activity is based on it. Because if you analyze the dependent and independent variable in a wrong way, or if you don't have a correct idea about this two, especially about this two variable, then your whole research is going to be a mess. So you should have a very good idea about this, which one is your dependent and which one is your independent variable. So dependent variable is the outcome, or we can say it's a testing variable, the one which we are going to test. Okay. And the second one is the independent variable. Independent variable is nothing but the one which is influencing the dependent variable. So that one is a independent. Now I will share one example. Please next slide. Proceed to next slide. Okay. Now I will share you with one example, like impact of occupational stress on family environment. Okay, if this is a statement like I want to know what is the impact of occupational stress on family environment. Can you tell me which one is your testing variable or the dependent variable? Anyone? Any one of you?
Once again, madam, once again. Once again.
Mr. Praveen?
Yes, ma'am.
You want to say anything?
Once again, madam, just not
Okay, once
clearly.
again.
Yes.
The impact of occupational stress on family environment of a person. Okay, if this is a statement, impact of occupational stress on family environment of a person, so which one is the dependent variable?
Occupation is the dependence variable. It can be
Right.
affected to the environment.
Right. So occupational stress is the dependent variable, because the much you will feel stress, the much you will have a effect on your family environment. And if you are not affected by your stress level, then obviously you will lead a happy life in your family. So this is why, so the one which we are testing, that is the occupational stress. This occupational stress is the outcome variable or the testing variable. Okay. And the dependent, this is the dependent variable, and the independent one is the family environment. If you have a cool and calm environment in your family, then obviously it won't affect the stress level also. So this way also we can say, so the one with which we are testing, the one with which we are working, and we want to see the impact. Okay, we want to see the impact of that variable, so that will come under the dependent variable. And the one which is influencing you, okay, the one which is influencing the dependent variable, that will come under the independent variable. So dependent variable is like we can't change the dependent variable, but whatever manipulation we can do, we can do those sort of manipulation in the independent variable, because this independent variable is in the hand of the researcher, where researcher can manipulate. Either researcher can increase or either researcher can decrease it. How increase and decrease takes place, like if I give one more example also, like the achievement test of a student is not affected by the noise of the sound. Okay. Somebody have raised your hand. Please come up. Shushena, Kalaguri, and Shilpa. Do you have any question? Sunena, sorry. Sunena, do you have any question? Okay. If you don't have any
No, ma'am.
question, okay, tell. Tell what you want to say. Okay, let me continue. So, like if I'm giving one more example, like the achievement of a student is not affected by the noise coming from the outside. Okay, so here the achievement, we are testing the achievement of the student. So this achievement is our main concern. So that's why this is the dependent variable. And the noise from outside can be manipulated. It can be either, increased or decreased by the researcher. Like when in a control environment, when the researcher is conducting the experiment with that particular student, and he or she want to see whether his achievement is really good or bad, but suddenly a noise when coming from the outside, what the researcher can do, researcher can just shut down the window, so that no noise can come, and he or she can coolly and calmly can give the exam. So this way we can manipulate it. Either if the researcher is not bothering about it, like researcher is not bothered about it, researchers have a thought in mind, he lets the noise come, but the student should give exam in this way, because this is very common problem. So we are not going to do anything. So this way, researcher either can manipulate the situation, researcher either not manipulate the situation. So this is in the hand of the researcher. Okay, whether he or she can manipulate it. So that's why this is a independent variable. Now you got a clear idea about the dependent and independent. Okay, now we are coming to how to import a data. Okay, so in SPSS, like if you want to import data from Excel to directly to SPSS, so we can go to this file tab, open. Then after that, we will go to the open tab. We will insert the data, selecting the file, and after that, it will automatically be transformed into the SPSS. So this way, we can import the data from Excel to SPSS. Okay, if you want to put any sort of data from Excel worksheet from Excel to SPSS, so you can do that. So this way we can do. We will come to the practical session. Okay, next slide. Now we will come little bit of statistical terms which are very important. So first one is the parameters. So parameters are nothing. These are the characteristic with which you are working. So like it can be a characteristics of a demographic. It can be a characteristics of a mean. It can be a characteristics of the variance. So whatever parameters we have selected, so it's actually detailed out about its characteristics. So parameter is nothing when you are defining each and every set of data that you have taken for your study. So that one will become under parameter. Now the statistics is the measures which we do with, like we can say statistic is a statistical measure computed from sample observation, the number of sample that you have observed in the open environment or in a closed environment. So whatever you are This Sunena is raising a hand. Do you have any question? Sunena, if you don't have any question, why are you raising the hand? If you have any question, please come up. Okay. Next one is standard error. So standard error is nothing. You have any question?
Hello, ma'am. Ma'am, what do you mean by standard error, ma'am?
Pardon, please.
What do you mean by standard error, ma'am?
I'm not getting. Voice is not actually clear. Others, can you hear what she is saying? I'm facing difficulties.
What do you mean by standard error, ma'am?
Standard error. Wait, I'm coming to the standard error.
Standard error, ma'am.
I'm completed. I'm coming to the standard
Ah,
error. Okay. So wait for a while. I will
okay,
come
ma'am.
each and every description. Okay, so standard error is nothing. Standard error is given. See, standard deviation of the sampling distribution of a statistics. Okay, the one which you have selected. So the one which we have selected from the observation, and the much it is being deviated. So that statistics is known as the standard error. Standard error is nothing. Standard error, we can say, is the standard deviation of the sampling distribution of a statistics. So standard deviation, first you should know what is the standard deviation. Standard deviation is nothing. When you are taking the observation for any, the candidate, for any respondent, this observation, if it is close to each other, like once you have taken 15, 16, 17, okay, and the last one that you have observed it's 25. So how much it is deviating from each other, like the minimum one is the 12 or 13, and the end one, like the last observation that you have taken, that is the 25. So how much it is deviating from one observation to another observation. So that is the standard deviation. Now, from this standard deviation, when you are calculating the sampling distribution, so while calculating this sampling distribution, you may get some kind of error. As I have told in the early session, like there will be a sampling error. Like when you are drawing sample also, while drawing sample also, you can get an error. So while calculating the deviation also, you can have an error. So that is a standard error. Next one is the test of significance. So test of significance is nothing whether you are accepting or rejecting. I am getting in clear. Okay. Test of significance is nothing. Test of significance is like when you have formulated the hypothesis, uh, whether this hypothesis you are going to accept or reject it, it depends on the results that you are getting. So that is the significance test. Okay, that is the significance test. So when Sunena is having some query, come up. Sunena, if you have any query, please come up.
No worry, ma'am. Understand, ma'am.
Is it okay?
Hi, yes, ma'am. Yes. Okay, ma'am.
Okay, okay. So test of significance is nothing. Test of significance when you have framed the hypothesis, and after framing the hypothesis, whether you are going to accept or reject the hypothesis. So there is some kind of margin, there is some kind of parameter. So when you are going to that parameter, like if I say like in examination, 40 is the pass marking. So if you are getting a 40 or above 40, that means you are passed. But if you are getting below 40, that means you are failed. So in the same way, in case of hypothesis also, like test of significance, when you are getting a some kind of result, we will come to the detail of what is the result. Okay, so when you are getting that parameter, that means your hypothesis is accepted. And if not, then it is rejected. So how it is being accepted, how it is being rejected, it actually depends upon the statement that you are framing for your hypothesis. Like in each and every like thesis or the research, we generally start with the null hypothesis. Null means no. We are stating that there is no relationship between the variables. Okay. So when you have conducted this test and the results that you are getting from the test, And if that test result is coming closer to 0.00 something, then there is no significance difference. But when it is coming above like 0.05, then there is significance difference. Understood? So this is the margin we can say. So when we are getting any sort of result within that margin, based on that, we are accepting or we are rejecting the hypothesis. So that is the simple. So the level, what is this level? What this level is the 5% and the 1%. So for science, we generally use science and engineering, we generally use the 1%, and for social science, we use the 5% level. Okay. Now we are coming to the p value. P value, already I have told you that there should be a margin. This margin is like the p value. So p value is the level of marginal significance within a statistical hypothesis representing the probability of occurring given event. So p value is, if you see the full form of the p value, that means actually the probability of occurring any sort of event. So whether the probability is 5% or 1%, the results that you are getting, from there only you become assured, like yes, there is a probability of occurring the incident. Yes, again we can say no, there is no probability. So based on that result, we accept or reject the hypothesis. This is a very basic criteria. When you are going for the quantitative research, you should have a clear idea about this. So when your value, your p value, we can say your p value is coming, is close to 0.000, that means there is no significant difference. Okay, sorry, 0.00, there is a significant difference between the two variables. Okay, but when it is coming above 0.05, then there is no significant difference. So the significant difference between the two variables, we doesn't find any sort of differences. So this is the basic criteria. Next one. Okay, so before applying any sort of test, whether we are going for the, the parametric or the non-parametric. Now, what is this parametric and non-parametric? We will come, like parametric test is nothing. Like when you are having a certain set of criteria, you can go for test A. Again, when those criteria are not matching, you can go for the, or you can opt for the test B. So that is a parametric and non-parametric. Now, what are those criteria? We will definitely come. But before opting any sort of test, whether it's a parametric, whether it's a non-parametric, first you have to check the outliers. Okay, you have to check the outliers. Outliers means that is the out of your consideration. Okay, the term outliers are nothing but that is a out of your consideration. Like in the last class also, I have already told you, like when we are dealing with students, we are concerned about the average, most of the average students. Like in a class, we know average performance and maximum, while the person who are scoring high as well as person who are scoring low are very less in number. Either the, the good performer as well as the bad performer are very less in number, but you will see most of the students are like somewhere near the average. So before conducting any sort of test, whether we should go for the parametric, whether we should go for the non-parametric, it can't be according to my wish, or it can't be according to your researcher's wish. It has to be tested. So based on those testing results, okay, you can opt for parametric and non-parametric. Okay. So in a class, when you are getting, like if you are conducting a test based on the 30 marks, 30 marks assessment you are conducting. So, and the maximum students are lying between 15 to 20. So that will be your main consideration. Okay. But when you are getting something around like 5, 10, and again between 28, 29. So these two layers are called the outliers. Okay. That is not, in the normal range. These are the excluded range which falls beyond the average. So that is the outliers. So we need to check the outliers. We have certain assumptions. So based on those assumptions, we should opt whether we should go for the parametric or the non-parametric test. And now if you have 500 data, 600 data, it's very common that you can have some kind of missing data. So when you are getting some kind of missing data, so this missing data you will see in the result, in the result view when you are conducting or when you are operating the SPSS. When you will go to the result section, so there you will get a missing data, this. So either you have to put those missing data into unmissing one, so that it should not look like a missing data, or either you can eliminate those data. So that is the missing data. Okay, like by mistake it can happen, like the data somewhere you have missed to put the actual value of those data, so you must check those things. So handle how to handle this missing data: transform, replace the missing data, choose method to replace the missing data. That means you have to, wherever you will find that marks, like in class also, like when you are conducting a test and like around 100 students, some of the marks, like 2 or 3 students are not being given in the award sheet. So what we'll do, we again recheck it and again we put the value, and again we will start doing the further assessment. So that is like a handling missing data. It's like that. Next, how to find out the outliers. So when you are going for the outliers, you want to check the outliers, whether your data is having any outliers or not. So you have to go to the analyze tab. Then after that, you have to go to descriptive. Following it, you will go to the explore. So there you have to put for which data you want to check the outliers. So in that basis, you can check it. Next slide. Okay, in hypothesis testing, there are two kind of tests. So one is the two tail and the other one is the one tail test. So anybody is having any idea about two tail, one tail test? Anyone? Anyone? Surena, please unmute yourself if you have any query. Okay. Do you have any idea about two tail, one test? Two-tail test is nothing when you are getting, the data in two dimension, not in two dimension. Like when we are saying this is also good, this is also good. Like you have a choice for cloth A, cloth B, but you are saying both are good or both are bad. So that is a two-tail. That this kind of test is known as a non-directional because it's not giving you any direction whether you should go for A or B. So they are not depicting anything. So that is a two-tail test. And the second one is the one-tail. One-tail test is a one-sided test because it will tell you whether the cloth A is good or the cloth B is good, or whether the test A is good or the test B is good. So in that way, it will give you the directional. So that's why two-tail test is known as a non-directional and the one-tail is the directional, as because they are providing you with some kind of direction. Next slide. Okay, so for testing the one-tail test, there are certain significance levels. So you should consider this significance level. For the science students, I'm not from the science background, but for social science, like we use these values. Okay, and for the science students, you can use the significance level of one value because you always test in the 1% significance level. But we social science students generally use the 5% level, as because we are dealing the things in a open environment and not in a controlled situation. But the science, almost all of the experiments are done in the control environment, so that's why we use the 1% level of significance. So for testing the two-tail test, so these are the critical values which are given below. So just see, and you should know this value. Okay, whenever you are testing this thing, and even if you are using the Excel file, so for Excel file you will use this one. Okay, but when you are coming to the SPSS or SPSS, you will use this two values, that is 0.005 and 0.001. But when you are working in a Excel, so you should know the critical value of 1.96 for 5% level if it is a two tail and 2.57 for one tail test. Okay, like whatever value, whatever results you are getting, so that result is exceeding this value or not. So based on that, the results will be interpreted in that way. And when we are coming to the one tail test for 5% level of significance is 1.645, and for 1% this is 2.33. So you should know all these four value. Okay, and if you are working only on that SPSS, then it is not mandatory to know this value because SPSS have their own critical value. It only tests on zero point zero 0.05 and zero point zero 0.01 level. But when you are working in the Excel, so you must know this value. Next slide. Okay, now we are coming to the demographic variable. What are these demographic variable? Demographic variable are also called the categorical variable. Categorical variable is nothing when you are dividing your variable into some kind of categories. Like gender, gender is your demography. Okay, gender is your demography, and in gender you are seeing male and female, even the third gender also. So that is a categorical variable. Like if you want to categorize the marital status, so married, unmarried, divorced, so that is the categorical variable. So in this way we divide the demographic variable into the category, and based on this category we find out the result whether it's significant for male or female, or for the marital status of married or unmarried. So based on that, so these, all of these, whatever, like the divisions you can see: gender, age group, education level, marital status, employment status. So when you are dividing this variable or categorizing this variable in one or two segment, so that comes under the categorical variable, and we also call it as a demographic variable. So when you are doing with the chapter 3, that is the research methodology chapter, so you must you know um, state your variables, like whatever variables you have shown, or whatever variables you are using for your research. And like if you are dividing those variables, it should be divided into categories, so you have to show those categories also, like you are dividing your variable in this manner, and you are categorizing into this way. So for each categories, you have to show the result when you are conducting research in SPSS or in the Excel. So whatever you are using. Next slide. Okay, standard deviation, as I have already told you, it's a variation or dispersion in the sets of values, that the values that you are using. So how much it is, spreading from the mean. Suppose your mean is 45, and if all the values that you are getting is near to 45, that means you are having a low standard deviation. That means your value will be some around zero point 0.5, 0.1, or it's near to 1, 1.2, 1.3, somewhere like this. But if you are having the one value is in 35 and the other value is in 10, that means there is a lots of dispersion. That means if your mean is 35 and you are getting most of the data around 10, 12, 15, that means there is a lot of dispersion. So this should not be there. When you are conducting your research, make sure about that. Like standard deviation, the much your standard deviation will be low, the much your data spread will be small. But when you are getting the spread out data, that means the mean will also the it's deviating from the mean, so it's not good. Okay, so try to choose those data which should be around your mean value. Okay, now these are the examples which are given for high standard deviation and the low standard deviation. See here already, for low standard deviation, all the data set are close to each other. But when you are getting a high standard deviation, like see 20, 80, 50, like these are the, the respondents values which are very far away from the mean score. Like your mean is like 100 and you are getting your data set like 20, 80, 50, 10, 90. So it's spread it throughout. So that means your data set is not actually good. It should be close to your mean. Now we are coming to the standard error of mean. Standard error of mean is nothing. It's a measure that quantifies the precision of sample mean estimate of the population. It indicates how much the sample mean is expected to vary from the true population. So like if your population mean is like 40, And again your sample mean, okay, the sample mean is nothing, the average of your sample. So if you're having a 10 sample, so make a sum of it and you divide by the 10, so that one is your sample mean. So how much your sample mean is deviating from the population mean. So if it deviates from the population mean far away, then again the standard error mean is very high. It's not good for your study. So if the sample error mean is low, then it's good for your study. So whenever you will find the error, okay, so none of the errors are good. So try to minimize the values of error, so you will get a very good result. So that is the fact. Next slide. Okay, now we are dividing this parametric and non-parametric test. Generally, in inferential statistics, we divide the test into two types. First one is the parametric and the second one is the non-parametric. So under parametric test, you will find one sample, two sample. Same for the non-parametric also, one sample, two sample. But for one sample, you have different tests like T test, Z test, and for the two sample, you have two group individual tests, Z test, paired sample, and for the two sample, you will find chi-square, Mann-Whitney, okay, median. Then for the paired, you have Wilcoxon, chi-square again, sign test. So these are the variations of tests. Apart from this, there are also some other tests, but generally we deal with these common type of tests. Okay. So next one, next slide. Now we are coming to what is this parametric test. Parametric test that makes assumption about the parameters of the population distribution. Like if your population is normally distributed, okay, if it's whatever as assumption, like assumption of homogeneity, okay, assumption of homogeneities are made, okay, then you can use the parametric test. But if it is not, then you have to use the non-parametric. Like if your population is not normally distributed. Normally distributed means we know that in a normal curve. Do you have any idea about the normal curve? Anyone is having any idea about normal curve or the probability curve? Anyone? Okay.
Probability curves means depends upon the getting the choice to achieve the correct answer. Curve means already set it some goal of data. We need to reach that goal of data. I think maybe I don't have that correct exactly, but technically I know that in the computer science I know that terms.
Okay. Okay. You get some?
Normal probability curve is a bell-shaped curve.
Okay. And what we do with this curve?
It's like 60 to 70% of data falls on the bell shape, and the two are on the other side of the bell.
But is it
2%.
always the same? Like 60 to 70 cases are falling in the bell shape and others are like lying outside the bell? Is it always
Not
the same?
no not every time.
Uh, okay.
It's about 95% within which falls within means 90 to maybe 90 to 95%, which falls within two that normal standard deviations.
It reached to threshold value, madam, nearly.
Okay. Bell-shaped curve, as Dipti Kulkarni had told, that obviously it's a bell-shaped curve, and through this bell-shaped curve, we try to find out many things. First of all, whether our results are falling within the critical values or not. The critical values that I've already told you, like whether it's falling within 1.96 or not, or beyond 1.96. If it's one-tailed test, first we have to see whether it's a one-tailed test or the two-tailed test. Okay, so based on that, we have to find out the critical value, like whether it's falling within 1.96 or beyond. Like most of the tests are two-tailed tests. Okay, hardly we get a one-tailed test or the directional test. Most of the tests are non-directional only, because we don't know whether this one is right or that one is right. So that's why we, on a safe side, just choose the the two-tailed test. Now we will see whether this observations or the that we have already gained from our the survey and all. So these observation, the results of these observations are falling within the critical value or outside the critical value. Now we need to check that. Again, we can also do with the help of bell shaped curve whether our the data that we are getting, the results that we are getting, it's near to mean or not. It's not near to mean, so we can check also that. So from there only we will able to know whether our sample mean is very much deviating from the population mean or not. So where is the error, how much is the error, we can able to find out the error also. Next we can also find out like the critical values that I have already told you. Again, through this bell shaped curve we can also form a histogram. Okay, with this bell shaped curve, we can also form a histogram. Histograms are little bit different from the bar graph because in bars the pillars are like separate, but in histograms the pillars or the bars are attached to each other. Now, from the bell shaped histogram, we can able to analyze like whether our data is skewed or it's non-skewed, whether it's a platycardic or leptocardic. Leptocardic, platycardic, it may also happen that you won't have an idea about it. It's nothing whether our bell-shaped curve is actually coming in a full bell-shaped or it's like a flat or it's a peak one. So if we are getting a the flat or the peak one, that means our results are not normal. Okay, but when we are getting full bell-shaped curve, that means our the we can say the results are normal. So when the results will be normal, mean, median, mode will be in the same line. But if it is not normal, then the mean will deviate from the median, median will be deviate from the mode. Okay, so that is the main criteria. We can say for that only we use the bell-shaped curve or the normal curve. We want to see whether our distribution is falling within the critical value or not, whether it's being deviating from the the critical value. If it is deviating, how much it is deviating, what is the shape of the bell-shaped curve, whether it's skewed or the the flattened one. If it is skewed, then it may having a negative value. If it is flattened, then again it's the parameters, others parameters are not okay. So for that only we generally use this bell shaped curve. Okay, from that only we will get an idea. See, in a normal scenario, when we are dealing with the human beings, so it is quite natural. We are not getting in the reality the bell-shaped curve because it's very difficult to bring the bell-shaped curve. But when you are dealing the data in a controlled environment, so you can control the whole situation. In that case, you can get a normal data. But when we are dealing with a human behavior, so in normal situation, in the open air situation, it's not possible to get a bell-shaped curve. But for that, what we do? We find out the something which is close to the normality. So whenever we are using the parametric test, we have to check the normality. If the data is normal, okay, fine, we can use the parametric test. If the data is not normal, then we will definitely go for the non-parametric test. Okay, next slide. Clear till here? Okay. Now, these are certain assumptions. So, people who are going for the quantitative analysis, so you must have an idea about all this. What are the assumptions for the parametric test? So, in parametric test, first assumption is like that the data come from a population that follow certain distribution. That distribution has to be a normal. Okay, if you are not having a normal distribution, as I have told, which one is the normal? Like in a class, if somebody is getting very high score and very low score, that means this is abnormal. So what we have to do? We have to, eliminate those data. But now you can ask, ma'am, is it possible like every time we are getting a, this kind of data and we will eliminate those data? We can do one thing, we can eliminate those data, or we have to transform those data into log so that the data can be transformed into normal one. We don't get the the abnormal data, so in that way we can normalize the data. Or either we can, if we are not getting a normal data, we can go for the non parametric. But many of the guides are having problem with the non-parametric test. I don't know why they are having a problem with the non-parametric. They always ask, please normalize your data so that we can go for the parametric test. But even if you go for the non-parametric test, that is not something, it's not abnormal. It's a normal, because you may get, because where the data from where you have collected, it's very normal that you can get a no abnormal data. And if you are getting those abnormal data, it's not possible to, again you have to transform those data into the normal one. So in every the, like, if you have selected a common study, but it depends upon the area where you are conducting the study. So in certain area you are getting a data normal because people are coming from the the average level, so that's why you are getting a normal data. But if you are conducting certain data in black zone area, or like something like red lighted area, so you can get a abnormal data, and for that you can obviously conduct the non-parametric. So there is nothing issue to conduct the non-parametric test. Next, what we can do the homogeneity. Homogeneity means assume the different samples have the same variance. So same, what is the term variance means? Variance means again how much your data is deviating from one data to another. Okay, so that one is the, so for that you have to do the homogeneity test. Again, if the homogeneity value is significant, then it's fine. If it is not significant, then you have to write in your interpretation that like the homogeneity test is not normal, and for that we are opting this one. Next one, you have to see whether the data are in interval or ratio. Okay, now do you have idea about the measures of scales? Anyone is having idea about the measure? Because until and unless you are having idea about the scales of measurement like interval, ratio data, you won't be able to conduct any research that is related with the quantitative study. So there are four kind of data. One is the nominal, ordinal, interval, ratio scale. So nominal scale is the normal. I mean the that is the lowest level. Lowest level. Okay. Nominal data. Please hear it properly. Nominal data means that is the first type of data, which is the basic or the foundation level of data, where we actually divide the data based on their name. The word nominal comes from the word name, like boys, girls, okay, male, female. So by name, when you are, segregating the sample. So these are the boys, so boys. These are the girls, so girls. So by name, when you are segregating the data, so that one comes under the nominal data. Next one is the ordinal data. Now you are arranging the data in certain kind of orders. When you are arranging the data, like there will be a nominal data, as soon as you are going from one level to another, what happens, like the basic one, the first one is the nominal, and after that the ordinal is coming. Now when you are coming to the ordinal, you will have the characteristics of the nominal as well as ordinal data. Both the characteristics are included. But when you are coming to the first layer of data, only you are having the nominal one, that is the when you are characterizing the variable by their names. But when you are coming to the ordinal data, you are characterizing the variables by name as well as with the help of orders. So in each and every type of data, plus one characteristics will get on added in that way. So ordinal data is nothing when you are ordering the data in some kind of level. So like gender for male, female. Again for marital status, like you are having an order of married, unmarried, or the divorced. Educational level, you can order the data in the base of primary, secondary. So these are the order level of data. But there is a problem with this ordinal data. Like this ordinal data, from one dimension to another dimension, you will not get the same interval. Understood? Like if a person is being ranked first and the person who is being ranked second as well as third, in these all these the levels, the what should I say, the margins are not equal. Like for first one only 2 marks difference, from second to third again 4 marks difference. So in that way, like you are not getting equal distance for each and every strata. Understood? So that is the ordinal one. Now we are coming to the interval data. Again, in interval data, the past two characteristics are there, and with that, the additional one, you will get the equal distance data. Okay, like past two characteristics, like the characteristics, like when you are categorizing the data with the help of names, with the help of orders. Now this time you are having one more category, one more characteristics, that is you are having a equal distance from one level to the another level. Like in the past one you are having a different, the margins. Now you are having equal. Like if first to second, the margin is 2, then obviously from second to third level margin is also 2. Okay, and the last one is the ratio data. Ratio data is nothing but in ratio data you are having all the three characteristics that already the others, the previous data is having. With that you are having absolute zero value. In interval data, this absolute zero value was, missing, but in the ratio data you are having an absolute zero value. That means, like if you are going to buy, a dress. Okay, if you are going to buy a dress for newborn baby, and you are asking to the shopkeeper that I want a zero size dress, so they will be able to know that means this zero size dress is for the newborn baby. Okay, so here the word zero doesn't signify actually zero. Zero means that is the most lowest one. But when you are coming to the ratio data, here zero means actually zero. That means if you're having a zero, the zero level of knowledge, that means not zero level of knowledge, because we can't say that none of the person is having a zero level of knowledge. If you're having a zero level of temperature, obviously there is no temperature, or we can say minimal, obviously zero temperature. The zero that actually designate the zero temperature, so there will be a zero temperature. So this is the way we divide the data. Now, in this parametric test, we don't deal with ordinal or the nominal data. We deal only with the interval and the ratio data. That is the third one and the fourth one. Okay, that means your data will be in a numerical order, not in the categorical order. That is, like we can say that education level, like primary, secondary, BA, BSc, not in that level. So whatever data you will generate for the parametric test, it should be in a numerical base. Okay, so one data is independent of another. That means the data, the marks that you have obtained and the marks that I have obtained, both are not dependent on each other, because my marks is my and your one is your. So that one is the independence. Higher statistical power, obviously for the parametric test, you have a greater precision, you have a greater, detection of the significance. So we can say it's a high level of, the test. So if we compare with the non-parametric one. And applicability to the hypothesis testing. So hypothesis testing is a scenario where we actually compare between the mean, we compare between the relationship. We can also see the regression, like what is the impact. Okay, again we can also compare between the mean groups. Okay, there are three groups of people, or we can say the three groups of categories, and what are their mean. So based on this group we can also compare their values also. So that is the parametric test. That is all about a parameter. So you should have, if your all these assumptions are met, then only you can go for the parametric test. Clear? Any question till now? Okay, next slide. But there are certain disadvantages of parametric tests. First one, these tests are very sensitive. Okay, if your assumptions are violated, then the results that you will get, that may not be a reliable or the valid one, because like you have seen, only one data is the deviating from the normal. Let's try with the parametric only, we won't change it. But the results that you are getting, that is not your real data. You will get, obviously you will get the result of it, like whenever you are conducting any sort of study with the unreal data also, so there also you will get some kind of results, but that result is not the real one, and obviously then your investigation or the research that you have conducted, it's not true or the reliable one. Next, we can say the limited applicability to the non-normal data. That already I have told you, the result that you are getting, it's a biased one. It will draw an incorrect conclusion. Requirement for the interval or the ratio data. Okay, so if your data is on ordinal or the categorical one, then obviously you won't be able to conduct any sort of analysis with the help of this data. Like when your data is in a non-numerical manner, like it is not coming on the basis of 14, 15, 16, it's a non-numerical one, then obviously you won't be able to generate any sort of the conclusion from that data. Next, we can say complexity in implementation. It's very complicated. Like you have to test each and every aspect. You have to test the homogeneity. So whenever you are conducting this, the parametric test, you have to follow each and every assumption. If those assumptions are met, and whenever you are writing the interpretation, also you have to see all the things very minutely, because one thing can go, for your side, but there are some other parameters also. On the basis of the other parameters also, you have to judge the results. So that's why whenever you are conducting any test with the help of the parametric, you have to see the other the sides that you are having. We should not decide with the help of one side of the coin. We should also decide with the help of the other part of the coin. So that is like that. Less robust with the small sample size. That means when you are conducting the parametric test with the help of the small sample, what happened? The results that you are getting, it's not being generalized. The last day I have already told you, like you have a thought in mind, let's conduct a study with the help of 150 sample and sufficient for my study. No, on the basis of your population characteristic, the much you are having a population, on the basis of that, you should, select your sample. So when you are conducting parametric tests with the help of small sample, so now anyone is having an idea what is the small sample and the large sample? Like how much we can consider the large and how much we can consider the small sample? Anyone? Any one of you? Are you listening? Like you are finding this session as interesting, or like I'm talking?
Less, less than 30 small sample, ma'am. More than 30 large sample.
Okay, okay. Others? Yes, Ramakrishna Reddy is very much right. Like when you are conducting any study with the help of 30 or below 30 sample, not 30, below 30. Okay, from 30, actually, the large sample actually starts. So below 30, when you are conducting any study, so that is a small sample. 30 and above is your large sample. But in reality, also, when you will conduct study with the help of only 50 samples, that is also not sufficient. Again, if you are conducting any study with the help of experimental method, okay, then it's okay, because for experimental study we need a less number of sample, and that sample should have some kind of variations. Okay, okay, Dr. Abdul Zalil. Okay, what do you
Yeah,
want to ask?
madam, what is a sample size if we are going for a
Hmm.
survey research? What should be the minimum number that we take?
In the you are present in the last class.
I was not, madam. I could not join
Okay,
yesterday.
that's why you are having a confusion. See, there is no such adequate, the sample size, because it's actually depends upon your population size. So the population size, based on your population size, your sample size will be determined. Again, in the last class also, I have shown one formula. With that formula, you can, come up with your sample size. People who are not actually present in the last class, I have shown one formula. With that formula also, you can come up with your sample size. Again, you can also conduct the online, the free online data testing are there. So if you want to determine, only in Google you will write determination of the sample size. So after when you search in a Google, so one window will open, and there they will ask about the n, total number of n, or the population they are going to ask, and based on that you will get a sample size. In
So
that,
is there a universal size that in
how
research
can
test?
how can there be a universal size? Like if you are conducting any study on.
Like for example, I want to conduct a research on maybe usage of teaching learning materials by the teachers, and I want to collect the data from a particular group.
Hmm.
So is it enough that if I have a data collection from 50 teachers or 60 teachers, or do
No,
we have no?
it's not like that because
Hmm.
it's depend upon your population size. So you have to take your sample size based on your population size. There is
So
one table.
what exactly is the definition of population when we say the population size here?
Population is like it can be your universe. Okay, so like
Okay.
there is one table is there. Just now I don't remember. I will show you the table. Let me search once. There is one table. So based on your population size, how much sample you should take, you will give. There is an indication on that table. Like if you're having a 1 lakh population, so based on those 1 lakh population, you can take 400, sample size or 450 sample
Yeah,
size. So there
sorry.
is one
So
table.
sorry to disturb you.
Hmm.
So 1 lakh that you mentioned as a population of a region or a
Hmm.
population of a.
No, like if you're conducting study on teachers,
Okay.
like
So
on that like state, how much is the population size of the teacher? So you have to find out that.
okay. Okay. Fine. Thank
Okay.
you. I got it. Got it. Thank you, madam.
So in like you are conducting any study on West Bengal, you can't conduct study on the basis of whole India. It's not possible because you won't get a clear idea about that also. So like you are conducting any study on West Bengal. So now you are conducting study on the secondary teacher in West Bengal. So from Google or from the the census data, you have to find out how much is the secondary data's teachers population almost. So you will get a rough idea. So based on those rough idea, you can generate your population. That is the the method generally we do. Again, when you are using the sample size data also, sample size, I mean the formula also, there also you have to put the population, how much your population. So based on your population only, you can determine your sample size because from where you are generating this sample size from the population only. So if you are not aware about your population, then how you will ever become aware about your sample size? So that's why I told you. It's clear, Dr.
Yeah,
Abdul.
yeah. Thank you, madam. Thank you so much.
Okay, okay, okay. Okay, next slide. Again, I'm giving one example. Like if you are conducting any study on the mental retarded students or the mental retarded people, okay. So, in which region, like mental retardation, you're having a very less number of, the population, but still, like if you are conducting the study in your zone, and there you have to find out how much is the mental retardation's population on the India basis you will get, or if you get on the basis of your own zone, then from there also you can find out or you can determine your sample size. Randomly, what happened in the last class also I have told you, like the guide what they do, they actually tell you take 500 samples, but you have whatever in research. Acha, Shweta, please unmute yourself. Do you have any question? Mute yourself. Do you have
No,
any
ma'am.
question?
ಅದು ಟಿಪ್ಪು ಪಾಲನ್ನು ಆಗೇದೇನು ಸೇರಿ ವೈದ್ಯರು ಆಯ್ತು ಅಂತ ಹೇಳಕ್ ಹಚ್ಚಿದ್ರು.
What?
ಇಲ್ಲ
You
ಫೋನ್
want to ask
ಹಚ್ಚಿದ್ರು
something?
ಸಿರಿ ವೇಟಿಂಗ್ ಆಗತ್ತೆ ಸಿರಿ ವೇಟ್ ಆಗ್ಯದ.
I'm not getting to you. Please type in. You
ಅದು
write
ಸಿರಿ
it in the
ಅನ್ನೋದು
chat box. I'm not getting what are you saying. Please write it in the chat box. What you want to ask?
Madam, you type in the chat box. You are not audible to anyone.
Okay. So if you are conducting any study on the mental retardation, so there also you have to find out like what is the population of the mental retardation. So, okay, so from there only you can generate your sample size. But that is not the way out that I have thought I will take 500 and 600 sample size. Please mute yourself, Shweta. So Rajni, please look after this Shweta because okay. Um, so from there only you can determine your sample size. Again, I have already told you that there is online sample size determination. There is a option is there. So from there also you can determine the sample size. Either in the last class I have shown you one of the formula with the sample size. Through that also you can determine your sample size. Okay. What happened in research, the researcher decides each and everything. Like if you have a thought in your mind, like I will take 500 data, I will not go beyond 500 data, you have to justify each and everything. Though you have determined previously, like I will not go beyond 500, I will take only 500 data. But when you are conducting or when you are writing your thesis, you have to show like how you have justified your sample size through formula, through table, whatever medium you want you can use. Because um, if you are following any one way, it's not wrong. Okay. So but you have to justify that with the help of this we have come to determine the data with the help of this method. But you have to justify it in each and every stage of your research. Whatever thing you are using, like if you are using survey also, like you have decided to use survey research, but why you are using this survey research and why not the other method like quasi experimental research or the experimental one, why you are not using, in each and every step you have to justify it. That is the thing. Because research is all about sequencing, research is all about your logical way of presenting your information, your the investigation. This is because of this I have done this. So everything you have to show. Okay. Next, we are coming to the t-test. So t-test we will show with the help of this dummy data. I have set one dummy data. So first we will come to the how we will conduct this t-test with the help of SPSS. Then we will come to its theoretical parts. I don't know how much I will be able to cover, but I will try my best. Rajni, please, you just stop share the screen. I will show the screen. Rajni, are you there? Let me see. I can show it now. Okay, now is it visible to all of you? SPSS, data view, is it visible?
Yes, it is visible.
Okay.
Yes,
If you
sir.
have
Yes,
any
ma'am.
problem with the full screen, you can slant your mobile. Okay, you can hold your mobile in a slanting way. I think it will come in a broad way. So from there you can see. Okay. Suppose we are conducting a study related with the occupational stress and the family environment. The first example that I have, stated, that is to test the impact of occupational stress on the family environment. So here I have taken two data that is related with the occupational stress and the family environment. Okay. Now we want to conduct the occupational stress. We want to see the occupational stress of the gender. Okay. How you will import a data? Let me show that. You have to start with this variable view. You can't put anything here at first. This data view, there are two window we can say. One is the data view and the other one is the variable view. So when you are plotting anything, you have to plot here first. Okay. So see, like male. Again, I'm writing here male. Wait. As because already male is given, so you can write male 1. Or you can write gender 1. Wait. Gender 1. Automatically, when you will give enter, or you will just click on this, the window, automatically this information will come up. So we want to give decimal point 0, and these are all numeric. Now what you have to do, you have to give a value. So gender we can divide in two ways. One is one for male and 2 for female. And okay, so this way you generally put the the data, we insert the data in this way, and here you have to give what sort of scale this is actually representing. So this one is the nominal, or like we are presenting one order, this one is ordinal scale actually. Okay, so this is the way we actually group the data. Now, when you will put 1, 1, 1, automatically see the male is coming. Again, when you will put 2, 2, 2, the female is coming. So this way you will fill up your row. And if you want something like shortcut, then just copy it and stretch it like this way. Again, you want to copy like this, stretch it like this way. So this is the most easiest way and the most fast we want to do it, instead of like putting 1, 1, 1, 1 or putting 2, 2, 2 in that way. Now we want to test the occupational stress of the gender. Okay. So we will go to the analyze. Then after that, we will go to the compare means independent sample. Okay. For independent sample, we will put the gender over here in the grouping variable and the occupational stress. As because occupational stress is the your testing variable, you will put it here. Okay, and after that, nothing you have to change here. You just define the group 1 as 1, group 2 as 2. Okay, now we'll come to the this wait. Now this is the result window. So see, for group statistics, how much you got for male. The total number of male is 12, female is 7. Mean of male is obviously high in compared to female. Okay, because male are nowadays taking much more stress in compared to female. Standard deviation, see 17, it's varying so much. If your data is representing like this, then obviously it's not good, but if you are getting, you can't help it. So this is the standard deviation and the standard error of mean. So we can see from the mean value only, the occupational stress level of the male candidates is higher in compared to female. Now, whether this your result is significant or not, through the second table only we will able to know. How we will able to know? Like this F ratio is nothing. This F ratio is resembling your variances, whether equal variances has been assumed or not. See, first see this one, the significant level. Okay, the significant level is 0.04. So 0.04 is obviously, we can say it's less than 0.05. So whenever you are having something less than 0.05, that means there is a significance difference. But when you are getting something beyond 0.05, then there is no significance difference. So this is the basic criteria which you should keep in mind whenever you are conducting SPSS. Even also when you are, doing, using other software like Amos also. For Amos also, you whatever software value you will get now for software value is different. Like you have to do with the help of 0.005. But when you are conducting the same thing with the help of, Excel, so for Excel, everything, your critical value surrounds around 1.96. But here you won't find the 1.96 system. Here you will find everything is around the 0.05 or 0.01 level. So see, here the significant value is obviously less than 0.05. So there is obviously, if we frame the null hypothesis that there is no significant difference between the male and female candidate in respect of occupational stress, but the results is showing obviously there is, the difference between the male and female in respect of occupational stress because your significance value is 0.043. Okay, and this F value is equal variances. That means both male and female are having equal variances. That means they are deviating much in respect. So here also see there is a significant difference, because for female you are having much more deviation, is like 24, and for the male it is only 17. So obviously there is a significant difference if we see the equal variances also. Now how much is the difference? It is the difference of 21. Like when you will minus this 110 with minus 89, you will get 21.155. So this is the mean difference. So whenever you are writing your interpretation, you will write in this way, that there is from the table, whatever table number, you obviously will put the table number. From the table, we found that there is significant difference between the male and female, as because the male mean value is this one and the female value is this one, and it is statistically significant because the p value is getting 0.043. So obviously there is a significant difference. Now what happened after giving this significant difference result? People just end their result. Okay, people just say, on this much differences we found between these two category, and that's why your result is significant, or if not significant, then not significant. But you have to give why it is significant, why not significant. In most of the research, most of the the candidates, what they do, they don't give the interpretation in a proper way, why you are finding the significant difference. Even if you are not finding the significant difference, you have to justify it. That is the work of the researcher. Only this much interpretation is not sufficient. Understood? Whatever calculation, see, whenever you are using the software is like how you are handling it. If you will give a favorable data, you will get a favorable result. If you are not giving the favorable data, you won't get the favorable result. That is the point. But in research, what you have to do, whatever data you are importing, and whatever data you are just presenting with the help of software, you have to justify it, why your data is like this, why your data is showing the significant difference. Okay, because male are, you can reason out like this way, because male, most of the male are the family holders. They have their workloads, they have their family pressure, so that's why male are much more stressed out in compared to female, because most of the females are married. So their thus their stress level is little bit less in compared to. So whatever other reason, because when you have conducted the investigation, you have find out the reason, you have talked with those people, so you have an idea about those, so you have to justify that. Clear? Is it okay? So this is the t-test. So t-test is nothing but when you are comparing between two groups, and before you are conducting the t-test, you have to use this, what you say, the normality testing thing. Now I will show how will you do the normality one. Wait, just a second. Now again it is visible, your data view, calculation part. Okay. Others are not talking so much. Why? Either you are not understanding whatever I am saying. Okay, now we will do the normality testing. Analyze, descriptive, explore. Okay. Now you go for the statistics. So here you will see the outliers. You will just tap on the outliers, continue, then plot. You want to see the normality plot. Okay, so normality plot. Options are by default, it's already been given, exclude the cases like, so you don't have to do anything here, and just press to OK. See, wait, again I have to show this one. Stop sharing. So QQ plot is one kind of plot. Any question? QQ plot is one kind of plot. that you can use for the normality testing. See here, you can see all these dots or bullets. So these are the outliers. Understood? As I was saying, you have to check the the outliers. So first you need to check whether there are outliers or not. If there are outliers, then what you have to do, you have to exclude these outliers, or you have to transform these outliers into the normal one. Okay, either you can exclude it or you have to transform it into the normal one, because most of us, we are dealing with the average, the people. So that is our main concern, because when we are generalizing our study, this generalization is based on the average people and not on the the outliers. So that's why we need to consider, we should not consider this outlier. Obviously outliers is a deep concern. What we can do, we can put this outliers into the case analysis for research. Like when we have conducted the study, we have found that most of the average students or most of the average people are lying here. We have found this for these people. But on the part of other side, we have found some of the exceptional cases. Now put this exceptional cases as a case study in your research. So these 2, 3, 4 people are exceptional. Why they are exceptional? They are not feeling occupational stress because they are very much punctual about their duties. They are like doing everything on time. Whatever reasons you want to put, whatever reasons you have found while you have conducted your study. So these are the excluded. That's why they are not so much of stressed out. So these are the excluded cases. Okay, so in that way, you can put a case analysis and you can, set this outliers in this way. Understood? Okay. Now we are coming to one sample t-test. So any problem with this t-test? Okay. Just a second. Now we will come to one sample t-test. Okay, so in t-test only you have so many of variation, but most of us use this one only. So this way we will go to one sample t-test and we are using this one, occupational stress. So keep your test value as 0. Now press OK. See, in one sample t-test, the occupational stress, like on 19 students you have conducted the the occupational stress, and your mean value is this one. Now test value, when you have put your test value as 0, you are getting this one as your result, and it is significant. If you want to put test value, like in our normal life, we obviously feel some sort of stress. Is not like our life is full of cool and calm. So we can put here test value as test 10. Like 10% of people, people have 10% of stress level. Okay, we have assumed that people are having a 10% of stress level because of this modernity in their life. Now we have put here 10, and now we will see the result. See, when you have put your test value, see the table 2, when you have put, okay, you can't see that this one, wait, this is the problem. 100 times I have to change it. See, now it is visible.
Yes.
You can see the result.
Yes, madam.
Okay.
Yes, madam.
Okay. In the first one, we have put the test value as 0. We are assuming that people are not having stress. This is the basic assumption. And based on that, we got this mean value. After that, we decided that it's not like that people are not having stress in their life. We have assumed that people are having a 10% of stress in their life. Now, with this test value, we will test whether it's significant or not. So, see, the significance level, that is SIG 2-tell test, is 0.000. So 0.000 is, less than 0.05. That one, your result is significant. Okay, that means your result is significant. So there is significant, no such significant, we can say there is significant difference in the occupational stress of the people that they are suffering. So in this way, we can use the one sample t-test. Understood? But for using the one sample t-test, you have to know, you have an idea about this test value. Like if you are conducting that, one sample t-test with the help of achievement, the achievement result or the academic result. So we all know that 40% is the pass mark. Okay. Now in this test value, we will put the 40. Now, whatever results we are getting with the help of that, the results that we are getting in the sig value, that result will indicate whether your result is significant or not. So based on that, you will do your one sample t test. Understood? Okay, one more thing that I will show in the t test only. Just a second. That is a paired sample t-test. Again, you will click on the analyze, come to compare means, after that paired sample t-test. Now in this paired sample t-test, one test you have applied before the intervention and one test you have applied after the intervention. Now you want to see whether there is any difference between the test 1 and test 2. So like here I have data like before I will put here and the after I will put here. Okay, options by default are everything is given. You just click on the continue and then okay. Now we will show again the result portion. Just a second. See in the result portion what we can see that for the before mean was 63 and the after mean was 95. Okay, so between before and after the correlation is very less, that is 0.168, that is very less correlation. That means there is no relationship between the before and after. It's not like that before you got a poor result and after you will get a high result. So for this we don't find any though there is a positive relationship, but the relationship is very poor and the result is also not significant. Now what we can see that the significant, see in the third table, the significance level is 0.000. That means there is significant difference between before and after result. Okay, so the before result is less and the after result is obviously high. So if we put in this way, like we are conducting a research on any sort of drugs and you want to see the effect of that drug. So you have applied two kinds of drug for sleep amnesia, okay, for any kind of sleep disorder. For the first time, you have given the drug one, and by giving the drug one, you want to see how much is the effect. And you have seen that for the drug one, you are getting the effect level is 63.89, and for the drug two, it is 95. So obviously we can say that the drug 2 is very much, the helpful or the very much potential drug which actually help to cure the sleep disorder of the people. So obviously there is difference between the drug 1 and the drug 2. We are saying that there is a difference with the drug 1 and the drug 2 because with this the significant value. Understood? Clear? Is it clear to everyone?
Yes, madam.
Yes, ma'am.
Now I'm stop this. Now we will come to the little bit of the PPT portion. See, we have done this t-test. 3 types of t-test are there. So based on your requirement, you can use this t-test for when you are comparing between the two group. Okay, please change the slide. Ranjit, please change the slide. Are you there? I don't know if she's there or not. Okay, so there are two kinds of group. If there are two kinds of group, you can apply the t-test. But if you are having a three kinds of group or the three categories of group, then you for that you can't apply the t-test. For that you have to apply the ANOVA. So now we will come to the ANOVA, how we can conduct the ANOVA with the help of SPSS. Okay, are you finding the session is interesting or like it's very bored? Please reply.
It's interesting.
ऐसे ही बोल रहा है कि सच में इंटरेस्टिंग है?
सच में interesting.
नहीं सच में मतलब are you getting the thing? Okay, प्रवीण बोलिए.
Madam, yes, interesting. But you are telling us these t-test compulsory it is required in that our research, no, madam, in our research topic. So we have to apply this t-test in my project. Actually, my project is automation scaling, madam. Measurements of whatever the test we have said. That CPU measurements, memory, like that, all the graphs will be going on like this, madam. Now I'm preparing the graphs also. So is it compulsory t-test is applied in our research?
It's depend upon your hypothesis and objective. The hypothesis and objective that you have selected. So if there is any categorical variable, I don't know about the the thing, what
Yes,
hypothesis
madam.
or objectives you have selected. If it is there, then obviously you have to apply. If not, then it's not necessary. Because most of the the science students you can apply, mostly of you apply the regression analysis, the much
Yes,
I know.
madam.
So
Yeah,
now I
yeah.
will come to the regression analysis. Okay. So this regression analysis is very important, and obviously it's a little bit different from this t-test. So for t-test, when you are comparing between the group, see here also it's been given, when you are comparing between the group, obviously you can apply the t-test. But when you want to see the impact of certain thing, then obviously you can apply the regression. Okay. Let me come with the
Okay,
regression.
madam. Yeah. We understood very clearly, madam. Thank you very much.
Okay.
Yeah.
Okay. We will start with the regression. Uh, for regression, again, you have to go to the Analyze tab, and from Analyze, you will click on the linear. Okay, click on the linear, and by default, it's already given that occupational stress is your dependent, and the family environment is the independent variable. Now you will click on the statistics, the results that you want to see. Okay, it's already depends upon you. If you want to see all these parameters, obviously you can click on all this. If you don't want to see so much, but the main that it's very much requirement while conducting the regression analysis, that is your model fit, R change, okay, and obviously the R squared. So these are important, and the collinearity. Okay, collinearity diagnostic, that is from there you will be able to know about the tolerance value. And Darwin Watson, if you want to see the Darwin Watson, you can give. If you don't want to see, then it's fine. Okay, if you don't want to see, there is nothing wrong, because from significance value only you will get the result. Again, we will come to the plot for dependent. Why is your dependent? So put the dependent, the thing here in the y-axis, and the ZP red in the x-axis. Okay, continue. Then for save, here also in predicted value, what you want to see, if you want to see the unstandardized, standardized, and the adjusted one, so click on that. For residuals also, if you want to see only the unstandardized or the standardized, or if you want to see the both, so then you can click on the both. Okay, now these are not required, these are not mandatory. I don't know about your machine testing whether it's required or not. If it is required, then obviously you have to give, and if it is not, it's not. Then again continue. Option, in option everything is given, we are not going with the option, so we will just click on the continue. And the method we have done with the help of enter method, and just click to OK. Now we will come to the result portion. Okay. Okay. See, the first table is about what method you have entered. So it is about that. Okay, the first one is the what method you have entered. It is about that only. And here you have taken the dependent. You can see the result window. Is it visible?
Yes. Yes.
It
Yes,
is.
ma'am.
Okay.
It's
So whatever method you will enter, so it will be seen in the first table. So you have entered the enter method. There are other method like step way method is there. So we have done whatever calculations we have done with the help of enter method. So in the analysis or in the interpretation, you can write with the help of enter method. We have started with the model, or we have tested the model whether this model is fit or not. Second one is the model summary. So model summary is, see here, the R value. R is nothing but R is your correlation. Okay, R is nothing, R is your correlation. So more this R value is higher, more you will find your model is much more fit. The more you will find this R value is less, your model is not fit. It's like that. So like you have investigated, you have like devised one model. Okay, with that model you want to see whether whatever thing you have set for your parameters, whether those parameters are actually working with that model or not. It's like that. So in the model summary, you have to write all the thing, whatever things you want to show. It's depend upon the researcher. If you want to only show this four parameters, then it's fine. If you want to show the other thing, but the mandatory which are actually required, that is R square, adjusted R, standard error, R square change, F, and significance for the, and DF and DF2 you can see in the ANOVA tables. In the ANOVA table also the DF and DF2 is given. So if you don't want to show in the model summary, it's fine. Nothing is wrong. Now, the R value is like R, as I have told you, R value is the correlation value. So here correlation, we are seeing that 66.2% or the 0.66 to 0.662%, we can see the correlation value. Okay. This one is the R square. R square is nothing, but in R square, we can see that 0.438, that is 43.8% of the variation in occupational stress can be explained by changes in the family environment. That means when you have entered your family environment as an independent variable, what we can see that 43.8% of changes we can see in the the occupational stress. So this is the variation in the occupational stress that can be explained by changes in the family environment. That means when your family environment changes, your occupational stress come up to the 43.8%. Now we are coming to the adjusted R. So adjusted R value, adjusted R square. Adjusted R square is nothing, but it is the value, you can say that how much correlation you are adjusting with it. So that is the adjusted value. Okay, if you don't want to show the adjusted R square, that is also fine, but R and R square are mandatory, and R square change. So R square change is nothing. R square change, family environment is your predictor. That means family environment is predicting how much occupational stress you are having. So this family environment is your predictor. When the family environment increases or decreases, your occupational stress also increases or decreases. Like if you are having a cool family environment, obviously your occupational stress will decrease. If you are not having a cool family environment, then your occupational stress will increase. So R change is nothing. Adding family environment as a predictor increases the explained variance by 43.8%. After you add this family environment to the model, we can see that 43.8% of the differences we can see here in the occupational stress. Okay. Now we are coming to the F change. F change is the this is the value, the one which whatever value you are getting. Please mute yourself. F change is nothing. F change is the value, whatever value you are getting. So this is the result of this value. F change is your whatever result, like R squared, adjusted R, whatever value you got. So these are the parameters of F change which actually depicting all this result. And now whether this result is significant or not, it's showing that only in the significant range. Now this F change we can also say in the ANOVA table also you will find the F change or the F statistics also. F change and F statistics is the same. It is the measure how much model actually improves with the prediction compared to the model with the prediction level. So F change is nothing. It is a measure of how much your model improves. Okay. So your model can improve up to 13.271%. So that is the thing. Now we are coming to the ANOVA table. Okay, so in ANOVA table also, there are certain values which you have to interpret, like sum of square. First one is the sum of square. So why we do this ANOVA? We do this ANOVA whether this model that you have, generate this model is significant or not, whether you can use this model for your prediction or not. So that's why we are using this ANOVA. Any question? Okay. Praveen, you have question. Tell. Sorry, Praveen, if you have any question, please ask.
Yes, Praveen, do you have any question? You raised your hand.
Yeah, no, sir. Actually, yes, sir. Yes, madam. Madam, this is same phenomena we can apply already in that machine learning algorithms, in the machine learning tools, prediction something. Some same phenomena we can apply like this into the machine learning.
You can apply in the machine learning, but for machine learning, this R value has to be very high. Okay, this
Yes,
R value has to be very high. It should be close to 8. If it is not, then in many cases, what happens? You can't go with this regression analysis. But in social science, 60%,
yeah, okay.
66% is
Yeah,
fine with us. So we can apply this model. So it's like that.
Yes, Surendra Reddy, you are also want to ask some question.
Okay, tell.
Yeah, Mr. Surendra Reddy.
Yes, sir. Yes, sir.
Yeah, you had raised your hand. Is there any query from your side?
No, no issue, sir. Unfortunately, due to network issue, I have joined late, sir. That was the issue.
Okay. No issue. Okay. You can
Okay,
go.
sir. Thank you. Thank you.
Okay,
Anybody else having a question till today's session, till this point?
if you have any question, you may ask.
There it is a very vast chapter. It's a vast presentation, I know, but it's very informative. And I think you all are quite engaged with it. And here in this point, we required a proper continual interaction so that we also understand how much you are understanding the topic. Okay. So if the session is interactive, it will be better. We already spent 1.5 hours, more than that here. It's coming to be approximately 2 hours by 630. Okay. So after since having this long session, definitely there must be some queries and questions in your mind.
Till now, you have any question? Okay, now we are coming to the ANOVA table. So in ANOVA table, we actually see the total variation in occupational stress is explained by the family environment. So this is
Evelina, ma'am.
Yes.
Yeah. I just sorry for interrupt you. Could we please summarize the things as already these people are having the 2 hours interaction with you. I think it is quite.
The session you
ऐसा ना
have
होने लगे कि इनके
of
ऊपर
things.
अब ऐसा ना होने लगे कि सब ऊपर से जाना चालू हो जाए.
Okay, sir. Okay, I'm just.
We will take a separate session within a 15-14 days again.
Okay.
As we already planned that we are giving the sessions on research methodology and different things fortnightly. So there will be definitely next session after 14-15 days. So we will continue with you.
Okay, sir. Okay, sir. Thank you, sir. See, it's not from the very beginning only. I told you that so much are there, and for regression analysis, obviously you need a some kind of separate session. And I know as because from 2 hours, I'm just kicking your brain. So this ANOVA table is nothing but through this ANOVA table, in a simplest manner, I'm just stating this ANOVA table actually states whether your model that you have undertaken, whether your model is significant or not. Okay, you have this value in a simple manner. I can only say that you have this sum of square, you have the total sum of square. So you have to, present this value in your interpretation, and whether this whatever value you are getting, this value is significant or not, you need to see that through this sig value. Now you are getting a sig value of 0.002. That means we can say the model that you have applied for your study, okay, in whatever area, this model is significant because it's explaining 66.2%. So that is the thing. If we come to the coefficient table, in coefficient table, what we see? In coefficient table, we generally see that there are two type of data. One is the unstandardized and the one is the standardized. So unstandardized, under unstandardized, we have seen the constant, and that is 126.800. That is the base level occupational stress when no effect of family environment is considered. So when there is no family environment is being considered, so this is the base level. And when you are coming to the this value, that is the 0.210, this is the family environment. So every unit increase in the family environment, occupational stress decrease by 0.210. So when your family environment get increased, you are getting a cool environment, your occupational stress get decreased. So that is the thing. And the last table which generally we need for the science student, that is the collinearity diagnostic. So through this collinearity diagnostic only we will come to the tolerance value, as in the previous class also we are stating. So see, this value, this eigenvalue is close to 1. So when your tolerance value is close to 1, or the VF value, when it is close to 1, that means there is no multicollinearity issue. Multicollinearity is nothing but, one variable should not be correlated with the other. If all the variables get correlated with each other, then which is the main effect and which variable is having a less effect, you won't be able to know. So that is the collinearity diagnostic. Okay. So when you are having a value, eigenvalue is close to 1, you will see this both the value. When it is close to 1, the first one is close to 1, that means your tolerance level is good. And we can say that, this model is obviously good because all the variables are not correlated with one another. When you're having a too much of correlation with all the variables, then which are having the main effect and which are having the less effect, you won't be able to know. So that is the thing. Okay, so till here we have completed the regression. If you have any question regarding the session, you may ask it, and I will try to answer it. Anything?
Yeah, ma'am. Ma'am, in independent variable, is it possible in order to compare the data if it is in the form of ratios like 70 to 30, 60 to 40? For example, male to female. Say male is 30% and female is 70% of data. Is it possible to compare?
Please ask one more time. Well, like what you have said, like you are having a male female data.
Yeah. So the same data, occupational stress and family environment. So we have collected the data for males and females. So instead of 10-10, instead of getting the data of independent variables, 10 males and 10 females, say for example, we got 60-40 or 70-30, is it possible to compare?
So you can conduct the t-test for that. Independent t-test. For that, you have to select independent t-test, because in t-test also I have shown you three kinds of variations. One is the one sample, pair sample, and the other one is so you can do the thing with the help of independent t-test. With the help of independent t-test only you can apply when you are having a two categorical variable. But when you are having a three categorical variable like male, female, and third gender, when you're having this three categorical variable, you can't apply this t-test. For that, you have to apply the ANOVA. Understood?
Okay, thank you.
Is it okay?
Yes, yes, thank you. Thanks.
Okay. Any more question? Okay, so I don't think like people are having any questions. Either they have understood, either they don't have understood.
Then definitely, ma'am, your session was quite insightful and quite informative, and it's given lots of information about the SPSS and these statistical tools and all. Actually, it's a very big thing that people are not understanding about how this ANOVA is helping, how this T
It's
test is
also
helping.
true, sir. Like when I have started with this SPSS, you have lots of, the calculation with this SPSS. It is not possible in one session you will understand each and everything. Only you will get the general idea, like when to apply what. But how to interpret, that is the most important thing. So slowly when you will, with more familiar with
Basically,
SPSS.
interpretation is the very big thing. After
Yes.
you having all the numbers in your hand, and then interpretation and significance of each and every value, whether it's the t-test, p-set, ANOVA, cogmet, everything you have with you. But until or unless you are not able to interpret what these values are saying, it will difficult to be narrate into your thesis and something.
Right.
Thank you very much, ma'am, for these all informations.